Okay, so hello everyone. I'm Sachin. I am an engineer at Canonical working on the communities team. And today we are going to talk about cluster API. So Yalton, you want to take over for this session?
Yeah,
Okay.
so what I want to cover here is that to set a bit of a background of the session that we're going to have. So today, deploy MicroK8 cluster in every cloud. With few examples, obviously we are not going to deploy everywhere. We are preparing another session that this is a day zero operation. We're going to cover the type of deployment, how to access to the deployed cluster, cluster scaling up and down, and then managing the add-ons. And then the last session for now that we're going to do, it is day two operations, upgrade workload cluster, upgrade management cluster, and management cluster migration from the into the workload cluster. So we're planning one session every 2 weeks. So probably the next one is going to be in 2 weeks from now. One thing that I wanted to show is the layout that we have in the canonical Kubernetes solution. So we have two upstream solutions. One is a Charm Kubernetes, which is like a end-to-end Kubernetes oriented to a big data center. And then we have a MicroK8s, which is a lightweight, but with high availability, security, air gap, and a lot of functionalities. And this product is intended for edge devices and IoT. We have two ways to provision our clusters and then to do lifecycle management. So one is Juju, which is a canonical product. And with Juju, you can provision and lifecycle management infrastructure, but also the applications running on top with the full automation. And then the other one, and what we are covering today here, it's a cluster API. That this is basically like a upstream community tool. For those cases when the user is looking for a graphical interface, we have an alliance with Spectro Cloud, and that can be used for visual management of the infrastructure. And then by using this tool, we can deploy in a big number of infrastructure providers. So we basically said that we can deploy almost everywhere, including Openstack, including MATS, which are products we are very familiar, but also public clouds, and also on-prem if this is required. And from this, I think you can take over, Sachin.
Okay. Thanks, Yalton, for the introduction. So first of all, let's get into bare basics of what cluster API is, why is it used. So a cluster API is basically a custom Kubernetes project from the Kubernetes lifecycle management. And its entire job is to provide a Kubernetes style API for cluster creation, management, configuration, all the stuff for cluster lifecycle management. The concept is very simple. You have something called a management cluster. Think of it as kind of the control plane. If I want to make an analogy with Kubernetes, think of it as a control plane, and all these workload clusters that can be deployed on any cloud of your choice. But you just have to satisfy the requirement for that particular cloud, and you can just deploy it on any cloud, and the management cluster will take care of all these clusters that are in different clouds. So essentially, you just pass it on a cluster specs. And that cluster specs is in the management cluster with all these infrastructure providers, control plane, bootstrap providers, and also the upstream cluster API CRDs. These are used, consumed by all these things to provision your nodes in different clouds. So this is what basically cluster API is. Now, a bit more details into what everything does. So these are like different CRDs that are provided to us. And the first one is provided by the cluster API, which is I have shown in a bit gray shade here. These are upstream. Think of it as like interfaces that we have to satisfy for our particular cloud. So cluster API, upstream cluster API provides us with GCRDs, clusters, machine deployments, machine health checks. And now for a particular infrastructure, we have to provide our infrastructure specific CRDs like infrastructure clusters, infrastructure machines, and is it visible, like find visible infrastructure machine templates, all that stuff that you have to. So it's kind of color coded, so it should be easy to follow. And then control plane and bootstrap providers take care of bootstraps and control plane specific stuff of the workload clusters. So these are basically all the CRDs that you need to satisfy to make it run on a particular cloud, and the number of replicas that you want for that particular workload. Moving on a bit more like what it's a bit verbose of what this previous slide was. So Cluster API provide all these machine-specific CRDs. The job of Bootstrap provider is to turn whatever your VM or your server that will work as a node in the workload cluster into a Kubernetes node. Control plane providers provide with these CRDs that constantly reconciles your state into desired state, just manages the entire workload clusters. And infrastructure is infrastructure providers provide specific CRDs for a particular cloud. So let's say for AWS, Azure, you want particular infrastructure, you manage all the configuration from an infrastructure provider. So what are the use cases and benefits of using Cluster API rather than some other tools like Terraform or something? First of all, it's upstream projects. So the folks who manage Kubernetes, maintain it, also see and check out like if the project is going well. So it's kind of a bit verified, like it's you can trust it more. It helps you manage the lifecycle of your entire workload clusters, so you don't have to worry about if one workload goes out, then you have to particularly go on and manually manage it. And because of that stuff, it also becomes easier for these workloads to get upgraded easily, because now a central management cluster's job is to does all these upgradings, and so it becomes quite easily scaling, self-healing. All this stuff becomes very easy because there is a central management cluster that is maintaining all this stuff. So we have, as Canonical, for MicroK8s, we are working on two providers, Bootstrap and a control plane provider. It's similar to what Bootstrap provider does. Our MicroK8 specific boot providers generates a cloud init script and it turns a particular machine node into a Kubernetes node, a particular MicroK8 Kubernetes node essentially. Same goes for control plane provider. It takes a node and makes it into all those control plane specific agents and all that stuff that are required for a control plane. The links are provided here. If you want, I have pasted the GitHub repo, and you can go there and check out the links here too. This is something that we worked on, and this is a Cluster API book, and with all the implementations of different providers, Bootstrap, control plane, infrastructure providers. And so you can see MicroK8s is one of those few providers that provide both Bootstrap and control plane. So I think it's, apart from KubeADM, I think. So it's kind of good. We worked hard for it. So do give it a try if you get a chance to. Okay, so a quick demo. Let's see. This is going to be interesting. No, tab. Windows still not working. Tab it is. Okay. So in this demo, we are going to essentially see that how you can deploy a particular infrastructure to a particular set of infrastructure and a management cluster, and those different nodes are managed by that central management cluster, and what the configurations you need to set for that particular cloud provider. So first, for AWS, these can be found out in the repo under templates. I have given a link if you want to check out. You just need to set out a few basic configurations like cluster configurations for versions, how many replicas you want for these, control plane and worker nodes. The region, these are all AWS specific keys and secrets that you want. Hopefully I don't reveal any of mine. Yeah. So all of this can be are provided on the GitHub page and also in the cluster API book if you want to follow along. You just provide all this stuff, all these credentials. After the providing credentials, you just initialize your cluster by this. For Bootstrap and control plane, we provide MicroK8s. Also, if you have a cluster API config file inside in your .cluster API repository in your .cluster API folder, so you don't need to do that. It will be defaulted to MicroK8s. And then finally, you generate a cluster using this clusterctl generate command. So we'll see a quick demo for this AWS. Sorry, my Windows just bailed out on me, so I have to select different tabs every time.
Don't worry with that, Sachin, so we have time.
Okay. So as you can see on the first one, we install MicroK8s, and this MicroK8s instance is going to be working as our management cluster. Go on, wait for it to become ready. Yeah, now it's finally working. Yeah, the first few pod deployed for Calico nodes. And then we provide the configuration to the kubectl that we want. We enable DNS. You see here, we are enabling DNS for this. This is required. Waiting for the DNS pods to get restarted. Finally, it does. And then we do the clusterctl init for AWS with MicroK8s provider for Bootstrap and control plane providers. So it takes time. As you can see in the above terminal, it's downloading a lot of pods for cert managers, and then it will download the pods for CAPI, particular CAPI, and also then we will install MicroK8s related CRDs, Bootstrap and control plane in a moment. So as you can see in the top screen, we have cert managers provided by Upstream. We have a CAPI system pod, which has all the CAPI specific CRDs, CAPI MicroK8s control plane, and Bootstrap, which have all the CRDs we want for MicroK8s specific control plane and Bootstrap plane. This is the template that you get finally if you do. I don't know if you did. So when you do a clusterctl generate, you get this cluster.yaml with all these specific variables that you set. These variables are then digested into this particular YAML file. And now we will apply these manifest to the cluster, and this will deploy our worker nodes to AWS, and that will be managed by the MicroK8s instance we deploy as a management cluster locally. So we do that. We have applied it, and after applying, we see that machines are being deployed on AWS. It takes a bit time for the entire thing to come up. So quickly fast forward. Yeah. So the first thing that happens is that there is a control plane node that has to be provisioned and become ready for the rest of the stuff to kick on. So we have provider ID for that first one. This is in ready state now and running. And now we can also have, if we want to scrutinize like what happens in this particular nodes, then we have to generate a cluster config, kube config for these workload clusters. So for that, we just take the clusterctl get kubeconfig, put on the name of the cluster, and we have a kubeconfig file that we can use to essentially go and check the status of these nodes in the workload cluster. So if you can see, if you do that, use the kubeconfig for that and get nodes. This is the only node, which is the control plane, a control plane node in the above screen, which is in the ready state, and it's also in ready state here as a node. So the above shows machine, which is abstracted concept for nodes. Machine is the lowest of, it's very akin to how pods are in Kubernetes. It's the lowest unit of functioning here. And quickly fast forward. And so you can see finally we have all these nodes ready and working fine. In the above, you can see the machines, and in the below we had a clusterctl of our management cluster. And finally, we delete the particular when you are done with the stuff. This is for AWS. We can see quickly for a very similar thing happens for GCP and OpenStack. So we can quickly see one more example. This has happened, and then we can see for OpenStack, similar to that, we deploy these configs. We deploy these configs here with particular variables that we want. For Kubernetes, then this is very specific to OpenStack, and all this is very specific to OpenStack actually. Then finally, we initialize our infrastructure as OpenStack. The bootstrap and control plane will be MicroK8s. And then finally, we generate the cluster config manifest, and then apply that manifest to get our workload cluster. A quick video for this. Let's see. OpenStack. Go. Similar to the previous one, we have finally generated the manifest for that. And we will deploy three replicas for work machine for control plane, and 3 for workload for worker nodes, and for 125 version. We apply this here similar to the previous one, and then watch as the machine goes on. Similar to the previous one, control plane node has to come alive first, and then the rest of the stuff can go on from there. Quickly fast forwarding. See, the first control plane node is being provisioning. Fast forward. It's very similar in all the clouds. It's basically the same step over and over. You take all these specific variables, and then you apply those variables to the templates, and you have a workload manifest. Yeah, finally we have a running cluster with 3 control plane and 3 worker nodes. A final example, kind of redundant, but still worth showing, is for GCP. We can see the GCP one quickly. Wait, promise this is the last one. Similar to the above, we can have these for GCP. One thing to note is you need a very, for a particular cloud, you need to be careful of what these variables are. So for GCP, you have to make up your own credentials and also have your own image ID. And then finally, with all this configuration, you can have the infrastructure, and then you can apply and get your own infrastructure. Finally, a quick demo for this, and we are done. Similar to that one, I applied the manifest. It brought alive the first control plane, Going forward, very similar to the previous one. So I just skip forward to the end. It's very similar. How it goes. So finally, there you have it. So we had we have also the same thing for Azure, and also we are working for vSphere and stuff. But you can definitely do this kind of things with Cluster API for different clouds. You can also create your own manifest, try it out. If it's working, you can send us a PR and we will be happy to review and make it our own template. And so I think that is it from my side for this demo. Any questions? If anyone has a question, we can take it.
Thank you, Sachin. This is Musa here. Just wanted to ask you this. A very good presentation. Thank you. So just wanted to ask about this code which you were sharing it. Do you think we can try it somewhere? There is a repo for that one?
Oh, sure. Can you see it in the? I'll repaste it if it's required. So if you want the slides and if you want the all this flow code, you have it here. It has also the links to the particular project, the cluster API MicroK8s controller, control plane provider, and the Bootstrap provider, which has all these. In the README, you can find the particular information of how to do this. The repo that I shared has a manifest file for I think OpenStack and GCP, and also the that all the configuration file that I was showing here. You can take help of that. You can also go to the repositories README, and yeah, you can take that same information there too. If you have any, if you want any help, we are there on Slack, and also on Kubernetes discussed.
So Slack channel is this.
It's on upstream Kubernetes.
Okay.
In MicroK8s, I can also share the link.
Thank you. Yeah, the reason I'm asking is the first time I've joined it, so I just want.
Oh, sure, no problem.
Thank you very much. So my take is basically, is this from a MicroK8s perspective, is that we can use the MicroK8s cluster as a management cluster to manage other clusters.
Yeah.
Right.
Yeah, sure. You can use any cluster, but in this case, we had a microcluster that was running locally, and it was essentially managing all these workload clusters that were deployed in AWS, GCP, OpenStack. So this is how cluster API works.
Yeah.
So, any other question or?